All right, so now we have Unit 3, Objective 5, which is graphing polynomial functions. We have been graphing polynomial functions already. In Objective 2, the function came in standard form. No, it came in factored form. In Objective 4, which was the previous one, it came in standard form and we had to factor it. So now we are going to continue factoring, but this is a different way of factoring, is factoring by grouping. So here we go, is factoring by grouping. It's different because we have 4 terms. Notice that I have 1, 2, 3, 4. We have 4 terms. If we only had 3, we would call it a trinomial, but we have 4. So here are the steps. We have 4 steps. I'm going to follow along here, reading the steps and showing you what happened, and then we'll do other ones from beginning to end. The very first step on the very first problem over here, the polynomial is in front of us. It says to look for the greatest common factor. You always look for the GCF first, okay? I'm going to box my GCF here. That's my very first step, always, okay? Always look for a GCF. So I like to look at the numbers first. Let me zoom in so this can be a little bit bigger, and then I'll zoom out later. Oops, that was pretty big. Okay. All right, that was a lot of zooming. Okay, so notice that a 4x to the 4th, an 8x cubed, a negative 16x squared, and a negative 32x can all be divisible. All these numbers can be divisible by 4. But the variables can also be divisible by x. That's why the greatest common factor is 4x. Between all of them, I can divide all of them by 4x. Every single one of them can be divisible by 4x. That's why this 4x right here is our greatest common factor, okay? So when you divide 4x cubed by a 4x, when you divide a 4x to the 4th by a 4x, the result is x cubed. When you divide an 8 by 4, you get a positive 2. And an x cubed divided by an x is an x squared. When you divide a negative 16 by a 4, you get a negative 4. A x squared divided by an x is just an x. A negative 32 divided by 4 is a negative 8. And an x divided by an x reduces to a 1. And I don't have to write 8 times 1 because that's just 8. So see, I factor out the GCF from all 4 of the terms. And this is the 4 terms that are left over. The second step says factor out the GCF from the first pair and the second pair. So they're telling me to make 2 pairs. I'm going to make the first 2 terms a pair of terms. And then the second 2 terms, that's my second pair. So it's telling me factor out a GCF. So this is a different, this GCF is a different GCF than the original. They want me to look for a GCF for only the first 2. So only when I look at this first 2 values right here, between x cubed plus 2x squared, the GCF is x squared for the first 2 terms. So when you divide these 2 terms, each of them you divide them individually. When I divide x cubed by x squared, we get an x left over. And when I divide a 2x squared by a x squared, we get a positive 2 left over. So this value right here, this x squared times the quantity of x plus 2, is just this binomial right here with the x squared being factored out. Now I'm only going to look, I'm going to ignore everything else. Okay, if I would have covered this, only look at your negative 4x minus 8. What can you factor out from both of them? That would be a negative 4. Okay, so if I divide each of them separately by a negative 4, the negative 4 is our factor that we're factoring out. And the answer would be an x as left over from that division. And a negative 8 divided by a negative 4 is a positive 2. So I created another pair that I factored out the GCF for that pair. And then it says factor out the GCF 1 less time. So there's 3 times that I factored out GCFs. One that was for all, one that was for 2 separate, And now I'm going to factor out the GCF between these two things, these two terms. So I have my first pair and my second pair. What do they both of these pairs have in common? Well, they both have the parenthesis, the binomial x plus 2. So that's what we're factoring it out. We're factoring out the x plus 2 right here. So when I divide x plus 2 here, the x plus 2 cancels and we get an x squared left over. And when I divide this one by x plus 2, the x plus 2, I don't like to use the word cancel, reduces, and I have a negative 4 left over. Okay? So now I have the 4x, which was my original first GCF. I have my x plus 2, which is this GCF I just factored out here. And now I have a difference of squares. So check the factors. Can you factor again? Because I have a binomial or difference of squares, we factored out again. Okay? It is kind of hard to follow along when something was already solved. So let's do it again from beginning to end, following exactly the same 4 steps, but now you will see as it actually unfolds. Okay? All right, I'm going to write that same exact problem a little bit bigger because my handwriting has always been a little bigger. Plus 6x cubed minus 2x squared minus 6x. Okay, I write big, so let me zoom out. There we go. Just give me 1 second for the zooming out to happen. Okay, it's still going. There we go. Thank you. All right, so step number 1, I'm going to write it along as I work on it, okay? I'm going to look for a GCF for all 4 terms, all 4. I like to look at the numbers first. I can totally divide a 2 by a 2, a 6 is divisible by 2, a negative 2 is divisible by 2, a negative 6 is divisible by 2. Now I look at x values. I can definitely divide an x by an x, and this x squared can be divisible by an x, and so forth. So my GCF is 2x. I'm going to use a bracket instead of a parenthesis. It really doesn't matter. Notice that our previous example we used parentheses. I'm just going to use a bracket, okay? Because I like to keep things a little bit organized in a different way. So when you divide 2x to the 4th by the 2x that we are factoring over here, the answer is just an x cubed left over from that division. When you divide a 6 divided by a 2, you get a positive 3. An x cubed divided by an x is an x squared. A negative 2 divided by a 2 is a negative 1. I'm not going to write 1. If you do it, I don't care. I'll do it in pencil, maybe help make some of you happy. An x squared divided by an x is just an x. So I have a negative x. A negative 6 divided by 2 is a negative 3. And an x divided by an x reduces to just the invisible 1. 3 times 1 is 3. Cool. I made a smaller, it still has 4 terms, but they are smaller than what they used to be. They're smaller 4 terms. Okay, and then the step number 2 says, put them instead of 2 by 2. So I'm going to do 2 by 2s. So this is my first 2. This is my second 2. And I'm going to find a GCF for this 2 by 2. Okay? I have my original GCF is the one that I took out first. But between these 2 values here, x cubed plus 3x squared, if you only look at this and you ignore everything else, what can you factor out? You can factor out an x squared, right? So factoring out, I said this before and I'll keep repeating, is dividing out a factor. So when you divide an x cubed by an x squared, you get an x left over. When you divided 3x squared by an x, you get a positive 3 left over from that division. So there we go. I factored out an x squared and from these 2 terms. And I have x plus 3 as my answer. Now, for the next 2 terms, you get a totally different GCF, okay? They have 2, that's why they're separated into 2 by 2s, because they have different GCFs. What can I factor from these last 2 terms? Well, how about we factor out a negative 1? I will write it this time. So here we go. Okay, because if I don't write it, it kind of like may confuse some of you. All right. Remember, factoring out is a division. What is negative 1x divided by negative 1? Is just an x. What is negative 3 divided by negative 1? Is just a positive 3. Okay? Then notice that they said, now factor out the GCF one last time. Okay? So I'm going to group them 2 by 2s again. The first 2 and the next 2. So 2 by 2 again. And I'm going to take out the GCF from this 2. What do both of these guys have in common? Well, they both have the binomial, the x plus 3. That's the only thing they have in common. So let's factor out what they have in common. Let's repeat our original 2x. Let's factor out the x plus 3 that they both of them have in common. And let's put the leftover of that division in here. So when I divide the first by x plus 3, notice that the x plus 3 reduces and we get an x squared left over. When I divide the second term by an x plus 3, they also reduce and we get a negative 1 as our division, result of our division. Okay, now I don't need these brackets anymore. I am already done factoring. It took 2 times to group them 2 by 2s. Now I can just write 2x times x plus 3 times x squared minus 1. Whenever you have binomials, I have 2 binomials, check, okay, because we have binomials, check for difference of squares, difference of 2 squares, always check, okay? So there's my original GCF, the quantity of x plus 3, and there is our difference of squares, okay? We have x plus and x minus. X times x is our x squared. We put plus or minus, and to get a number 1, the factors are 1. So x plus 1, x minus 1. And there you go. We factor completely, okay? The steps is to look for a overall GCF, and then group them 2 by 2s, because right now they don't have anything in common, but if you group them 2 by 2s, you get to see that there's a binomial in common, and then you factor out that binomial, and you factor one more time. So our answer for number 1 is 2x times the quantity of x plus 3, x plus 1, and x minus 1. Okay. Let's do another one, just to make sure we understand it, okay? How about we do number 2? Here we go. I have a x cubed minus a 3x squared minus an x plus a 3. I will write the steps, and it helps you if you write the steps until you get used to it. Okay, let's look for a GCF for all of them. Okay, they cannot, this 2 can be divisible by 3, but these other 2 terms cannot. These 3 terms have x's, but this one does not. So we don't have anything common for all of them. So there is no common for all. The next step is to go 2 by 2s. So I'm going to group them, the first 2, the last 2. 2 by 2. And I'm going to look for a GCF. GCF. I'm going to look for a GCF for individuals 2 by 2s, okay? For this 2, we can factor out an x squared. Okay? Remember, factoring out is a division. An x cubed divided by an x squared is an x. A negative 3x squared divided by x squared is just a negative 3. So there we go. If we do it right, the next pair should also come out with x plus 3. Okay? Somehow we're going to see an x plus 3 show up. So what should we get to factor out here? I have a positive 3. I want to end up with negative 3. Well, if I divide a positive 3 by negative 1, I'll get that, right? So let's factor out a negative 1. So when I factor out a negative 1, I'm going to write the result of my division here. A negative x divided by negative 1 becomes positive x. A positive 3 divided by negative 1 becomes negative 3. I know I did it right. Do you know why? Because these 2 are the same. Okay? Because they are the same binomial. We want that. We are happy to see that. Put a little happy face. We want to see that same binomial show up. So I'm going to group them 2 by 2s again. 2 by 2s again. The first two and the last two. And I'm going to look for a brand new GCF. And guess what that GCF is going to be? It's going to be that binomial. Okay? That binomial is what I want to factor out from both of them. So x minus 3 is what I'm factoring out. If I divide this first term by x minus 3, the x minus 3 reduces and we get an x squared left over. If I divide this second pair of factors by x minus 3, the x minus 3 reduces and we get a minus 1. So there we go. Every time we have binomials, we stop, check for difference of squares. Do we have a difference of squares? Well, this one is not a difference of squares, but this other one is. So I'm going to repeat my first binomial, and for the second one, we're going to factor it. We just factored the same exact thing a minute ago. Is x plus 1, x minus 1. So there we go. Okay. Notice that the steps didn't change. It's just that sometimes we don't have a greatest common factor for all 4 of them. Okay. So x plus 3, x minus 1, and x plus 1. There we go. All right. I'm going to give you a hint on this number 3, but I want you to finish number 3. I'll get you started, but I want you to finish it. Okay. All right. So I have a negative x to the 4th minus a 4x cubed plus a 9x squared plus a 36x. Well, what is the steps? GCF for all. Okay. All right. This can be divisible by a negative 1. I can divide this one by a negative 1 as well. Okay, so negative 1 works, negative 1 works, negative 1 works. But this one can be divisible by an x, so negative 1x work for all of them. All right, I take care of the numbers, then I take care of the variables. So it looks like negative x is what I'm going to divide all of them by. So when I divide a negative x to the 4th by a negative x, we get a positive x cubed. A negative 4x cubed divided by negative x is a positive 4x squared. A positive 9 divided by a negative is a negative 9. X squared divided by an x is just an x. A positive 36 divided by a negative 1 is negative 36, and the x's reduces. All right. Now it's time for you to group them 2 by 2s. See if you can follow the steps from there. Okay? I want to see if you can continue the steps from there. So I'm going to write it down where I stopped. I stopped at negative x. I have a x cubed plus a 4x squared minus a 9x minus a 36. I'm going to stop right here. I want to see if you can give your best try. We'll talk about it in class. Finish it. I'm going to test you on it. Okay? I'm going to check on it. Okay. All right, let's go ahead. We're done practicing this. It takes practice. We're going to continue practice, but we're going to go ahead and graph it because our goal is to factor it completely so we can graph it. If you have not memorized that yet, what the even functions look like and what the odd functions look like, it's about time because we're almost done with the unit. Okay? And factoring, we have to have factors in front of us so we can find x-intercepts and y-intercepts, and the multiplicity of the x-intercepts is important. So here's another reminder. I think that's the 4th time that we're reminding on this shapes and steps. All right, so let's start one from beginning to end. We're going to factor completely. That's step number 1. Wait a minute. Let me break my rule here already. I want to go to step number 4 and step number 5. Okay, one of these days I'm going to remember to switch those steps right there. For some reason, I like looking at the degree and the sign of the leading coefficient from the standard form, okay? Because that's how we started with objective 1, I believe. So this is the standard form. So when you look at here, what is the highest degree? It's a 3, right? So the degree is 3, which is odd. And what is the leading coefficient? Is an invisible 1, which is positive. So I already know what kind of shape I'm going to be graphing. It starts in negative infinity, it's going to wiggle around, and it's going to end going up to positive infinity. So I know the shape of my graph very well. That's what I'm going to be doing over here. I just have to factor it completely so I know the x-intercepts and the y-intercept. So one of these years, I'm going to convince myself to move those number 4 and 5 to number 1 and 2. Okay? All right. So let's go ahead and factor completely because that is the actual step number 1, not Mrs. Meyer's broken rules here. Okay. So y equals x cubed plus 5x squared minus 4x minus 20. The first thing we're going to do is GCF for all. That's right. We're going to look for a GCF for all of them. Okay, that can be divisible by an x. Yep, that one too, but this one does not. And number 4 and 20 are divisible by 4, but 5 isn't. So there is no GCF. Okay, we don't always get a GCF for all. If we don't get a GCF for all, we can move on to group them 2 by 2s and look for a GCF individual for each pair. So we're gonna separate the first 2, separate the second 2. Okay, y equals. The first 2 terms can definitely take out a x squared. I gotta stop saying take out. Factor out an x squared, right? So take a look at this. X squared is our factor that we are factoring out. So an x cubed divided by x squared is an x. A 5x squared divided by an x is a positive 5. See? If we do it right, guys, if we keep our eye on the ball here, we want to make an x plus 5 show up from here, okay? So what should I factor out? Well, think about negative 20. Negative 20 divided by what gives me a positive 5? Well, if I divide it by a negative 4. Divided by a negative 4. So, sorry, that's the bell. So divided by a negative 4. A negative 4x divided by a negative 4 is just a positive x. Starting to look good. A negative 20 divided by a negative 4 is a positive 5. It looks good. There we go. Okay? All right, and then you say, what do I do? Well, now you group them 2 by 2s again, and then you take out, you factor out that binomial, okay? That is the GCF. The binomial is what they both have in common. The first group, okay, the first set of factors and the second set of factors have that binomial in common. We want to factor out that binomial. So x plus 5 is the divisor. We are dividing both of them by x plus 5 here, and I'm dividing this by x plus 5. So the x plus 5 reduces, and we have an x squared as the answer. The x plus 5 reduces, and we have a minus 4 as the answer. So we are almost done. Every time we have a binomials, we check for what? For difference of squares. That's right. We check it for difference of squares. Okay. There we go. I see right away a difference of squares right here. Our final answer is x plus 5. And then this one, we're going to get x times x gives us x squared. A positive and a negative. And then the two values that multiply that gives us 4 is 2. So there we go. We did it. Okay. So that is the complete factored form. Let's write it over here. Y equals x plus 5 times the quantity of x plus 2 times the quantity of x minus 2. There we go. It's fully factored. We know what shape we're going to be drawing, sketching. So let's find the x-intercepts and the multiplicity, because the multiplicity is going to tell us if it's bouncing or crossing. So we're going to set the y to be 0, okay? That's 0 equals, and then we're going to have our factors, x plus 5 x plus 2, and x minus 2. Let's set each of the factors equal to 0, okay? So I'm going to set x plus 5 equals 0, x plus 2 equals 0, x minus 2 equals 0. And then we solve it, okay? I'm going to subtract the 5 to the other side. We're going to get x equals negative 5. That's one of our x-intercept. I'm going to subtract the 2. We're going to get x equals negative 2. That's another one. I'm going to add the 2, and I'm going to get x equals positive 2. So there's 3 x-intercept. I only see that happening once, the negative 2 showing up once, and the positive 2 showing up once. So that's multiplicity 1 for all of them. If it is an odd multiplicity, odd means we cross. Okay? If it's even, it means we bounce. All right? Got to remind yourselves of that. Before we go, we got to find the y-intercept. So the y-intercept. Okay? You have two options, and I'm going to do both for you to see. Okay? You can either use the original standard form, or you can use the factored form. They're equivalent. One is all multiplied in, standard, and one is factored out. So y equals x cubed plus 5x squared minus 4x minus 20, or it does not matter. Y equals the quantity of x plus 5, the quantity of x plus 2, and quantity of x minus 2. It really doesn't matter which one you want, and I'm going to show you which one is the easiest. Okay? I like the standard form first, because if I substitute the x's for a 0, I'm looking for the y, so I don't want the x's. I will get y equals 0 cubed is 0, plus 5 times 0, well, 0 squared is 0, and 5 times 0 is still a 0. Negative 4 times a 0 is still a 0. And then I just have a negative 20. So 0 plus 0 minus 0 is 0, and we get the y-intercept of negative 20, which is the constant in the back right here. Okay? Is the constant in the back. Would I have gotten the same answer if I used the factored form? Yes, you would have gotten the same exact answer. You could have plugged in a 0 here, a 0 here, and a 0 here, because we don't want the x's, we want the y-intercept. 0 plus 5 is 5. 0 plus 2 is 2. 0 minus 2 is negative 2. And when you multiply this, you get that 2 times 5 is 10 times a negative 2, which is negative 20. So see, that wasn't hard, but this one was a lot easier. Okay, especially when you get the hang of looking at the standard form. Is it just the constant in the back? Yes, if it is a constant. Okay, if it is not a constant, it is not. So be careful. Don't shortcut things if you don't understand it. Plug it in and solve it. So our y-intercept is negative 20. We plug in 0 for x. That's why we plugged it in. That's why we plugged in, and we got a negative 20 for y. I think we're ready. We know the shape. We know the y-intercept. We know the x-intercepts and what happens at the x-intercepts. So I'm going to label, there's negative 1, 2, 3, 4. I need a little bit room for my negative 5. That's one of my x-intercepts. I have negative 2. Let me label. And we have a positive 2. Let me label that as well. And we have our y-intercept. Let's just write it right down here, negative 20. So now I know exactly what shape it is. Let's make sure it happens here. Let's go lightly, cross, cross, cross the y-intercept, and another x-intercept. So there we go. We got it. Okay, go lightly until you get the shape, and we're done. So our factoring skills by grouping, and then it got us to the point where we already know what to do, is finding the x-intercepts, multiplicity, y-intercept, etc. Okay? All right, the last one, I'm going to get you started, but you will finish it, okay? It's saying, if you have f of x and you subtract g of x, what happens? I've never seen this before, Ms. Myers. I know. It's saying if you have two functions and you subtract them from each other. Okay, let's give it a try, okay? Maybe, someone might cancel this question, but let's give it a try. It's telling me, if I give you two different functions, the f function and the g function, I have the f of x function, I want you to subtract the g of x function. Can you create a new interesting thing. Sure can. Here's the f of x function. I'm going to highlight the f of x. The f of x is negative 2x to the fourth plus 8x cubed. The g of x, I'm going to underline it in pink. This is the g of x right here. Not underline it, box it. I want you to subtract the g of x from the f of x. Okay? They don't combine, but let's write them together. So here's my f of x first, subtraction, and then comes the g of x. Because we have subtraction, we got to be super careful, okay? I'm going to put a parenthesis here because I really don't know what's coming. Okay, so originally I have the f of x, which is negative 2x to the fourth plus 8x cubed. That's just what it is, my f of x. I'm going to write my g of x right here, which is negative 2x squared plus 8x. That's it. It's just our f of x, and I'm subtracting the g of x. But because subtraction is always, like you have to be careful with subtraction, we need to distribute. That's why we use the parentheses, okay? You need to distribute that subtraction to both terms. If I was subtracting just a one term, okay, I would still need a parenthesis because it could be a negative and a negative. So, negative 2x to the fourth plus 8x cubed. And then I am subtracting a negative, so it's going to become a plus 2x squared. And a minus times a positive 8 here becomes a negative 8x. So we created a brand new function. It is the y equals. It says y equals right here. Y equals f of x minus g of x. So we created our own set of 4. Can you factor it? Let me give you a hint. Look for a GCF for all, okay? Can you take it from there? So that's it. I'm going to write it down exactly where I stopped so I can catch up with you in class. I would love to give this as a challenge in class to see how many of you finished it, okay? As points, participation, whatnot. All right, good luck with the lesson. Bye.